Okay, here is a proper video for my PPE. Okay, so the first one is a helmet. Okay, this is a normal safety helmet where it doesn't have the fire shield. And then this is a safety jacket. Okay, I don't have my FKPE lab jacket right now, so I'm wearing my intern one. Okay, and then we have the safety boot. It is a must to wear safety boot in power plant. And then for clothes, actually you cannot wear a jersey material to enter a power plant or a site because it is easily get burned. Okay, so you need to find a suitable material. Okay, and I don't have actually glove right now, but usually when we enter a voltage room, LVSB room or HVSB, okay, we will wear the glove. Okay, this PPE we use when we want to do switching. Okay, and then I will close up. This is an earplug. Okay, because in that room it's actually very noisy, so you need to wear this to protect your hearing.
Hi, Assalamualaikum. My name is Haniza Syairah binti Arman. For this week, I'm going to talk about the operation to turn on the LVSB. Okay, before we start our operation, we must wear our PPE, okay, such as safety helmet, safety boot, fireproof jacket, and then you must wear glove during you do the operation, and then the several PPE that related to our operation. Alright, before we doing the operation, we need to take note the several things, such as we need to apply the permit 1 month early to make sure that you can come into the LV room. Okay, next we need to notify the consumer either we need to supply the power off or to turn off the supply. So this is for their safety. Okay, if we supply the power without notify them, they will burn out at the site. Okay, the third thing is we need to checking the fire extinguisher in the LV room. Okay, this is the precaution purpose. Okay, so the fourth thing is we must have the first aid chart. Okay, in the first aid chart, there are the technique to do the CPR. Okay, so the next thing is the LV room. We must have the very important thing is single line diagram, or we can call it as the schematic diagram for the LV system. Okay, why we need the single line diagram? Because from the single line diagram we can know where the cable that connect to each other. Okay, so next we need to have a rubber mat in front of the panel LVSB. So this is for safety, our safety, to do the maintenance. Okay, next we need to checking the logbook. So from the logbook, we can know the history of the LVSB maintenance. So we can identify what is the problem of the LVSB. Okay, what is the condition in the LVSB. Okay, we can know the last maintenance for the LVSB. Okay, lastly we need to bring the tools that relate to the we need to bring the tool related with our operation that we are going to do later. Alright, before we start our operation, we need to know how many LVSB in the LV room. Alright, Second, you need to wear glove before you do the operation. Alright, this is the LVSB number 1. This is LVSB number 2. This is the ACB number ACB for LVSB number 1. This is the ACB for LVSB number 2. Alright, this is the outgoing load. Okay. So the first thing you need to make sure the outgoing load in off condition before we supply the power. Okay. Next, we need to make sure ACB in the off condition. Okay. Next, we need to make sure LVSB in the off condition, and then we need to turn on incoming supply for the LVSB. This one. Okay. Okay, next we need to checking the main supply at the LVSB. This one, we need to checking the main supply, either the power we supply incoming or not. Okay. After that, we need to connect ACB into the bus bar. Alright. To do that, we need to make sure ACB in the off condition, and then you need to take the handling to connect the ACB into the bus bar. This is the handling to connect ACB, to connect the ACB into the bus bar. Alright. To do that, we need to make sure ACB in the off condition, and then ACB in. Okay, we need to make sure ACB in isolate condition. So we must make it to connect condition. Okay. At this panel, we can see either the ACB in the isolate condition or connect condition. Okay, we need to change the status ACB to the connect condition. Okay. To connect the ACB condition, we need to use this one. This is the handling to connect the ACB into the bus bar. So you need to take it in the LVSB, in this side. We can open this, and then you take the handling inside this. Okay. Then you put it in the slot, and then you turn it to a clockwise until the ACB change to the connect condition. This one. You need to turn it as a clockwise until it change to the connect condition. Right. After ACB change to the connect condition, in order to give a bus supply, we need to turn on the ACB. Before we turn on ACB, we must to make sure the coil charge first. In this ACB, we have a coil, so we need to charge it before we turn on the ACB. Alright, in this panel, we can see either the ACB is charged or not. Okay, if not, we need to charge manually, because ACB coil take time to charge automatically. So in this ACB, we have a pull to charge it. So how we we can do the charge manually. So during the charge manually, we need to pulling the handle upward and downward like this until the coil charge. When the coil charge, we need to turn on ACB and make sure before we turn on the ACB, we need to make sure that we standing on the rubber mat before we turn on this one, because if anything happen, we can flow. The current can flow through your body until to the ground, right? So ACB in on condition, this one we can on. We just push the button and then the ACB will turn on. Okay, ACB in on condition, then checking the bus bar if they energized or not. So we can checking at this one. We can checking the bus bar is connect or not. If the lamp is showing the light, so meaning that the bus bar is energized. So after that, we can supply the power to the consumer side, right? We will turn on the supply from the transformer, and then the what we call that, we can supply the power to the consumer side. Before we turn on the supply, we need to notify the consumer at the site that we are going to turn on our supply, to give a supply for them.
Assalamualaikum, my name is Amirul Haziq bin Jeffrey and my metric number is AE190038, and today I will talk about procedure of MCCB. Before turning on the MCCB, we need to inform the consumer for our safety, and after that, after we inform the consumer and the consumer have proceed of our project, first we need to turn on the power factor capacitor to make sure the power factor regulator can monitor the system. And after that, after we have turned on the power factor capacitor, then we can proceed to turn on the MCCB. We can proceed to turn on the MCCB. After we have turned on the MCCB, we can check the current status. If there is any usage of the MCCB, the increment will be shown. For that, after we have turned on the MCCB, we can know about the current voltage and other thing that the consumer are using. After that, after settle up those, we can go to the second experiment, that is we can turn on the MSB number 2. For the MSB number 2, we can use the same step, that is first we need to turn on the incoming supply. After we have turned on the incoming supply, we can check the incoming supply and the incoming voltage of the consumer. After that, we need to connect the ACB into the bus bar. To make the function to connect the ACB into the bus bar, the procedure to connect the ACB into the bus bar is, first we need to make sure that the ACB is in off position. Therefore, when we need to insert the charging handle while pushing the button. The charging handle we can get inside the ACB compartment. After that, when we have insert the charging handle and while pushing the button, we need to turn the charging handle clockwise until the status are changed to connect positions. We need to rotate the charging handle until the connect position are changed, and after that, after the connect position are changed, we can put back the charging handle into the ACB compartment. When we have put back the charging handle into the ACB compartment, there we can charge the ACB by lifting the lever a few times. For the MCCB is also the same. We need to charge the ACB before we need to use it. And when we have charged the ACB and it has shown that we can use it, then we can turn on the ACB. After we have turned on the ACB, we can check the bus bar in a stable condition, such as we can look for the voltage, we can look for the supply, we can look for the currents. And after we have checked the bus bar in a stable condition, we can give the power supply to the consumer. But before we give the power supply, we need to ask them first whether they need it or not. And when they say they need it, so then we can give them the power supply. For the power supply to give, first off, we need to turn on the power factor capacitors, such as the first experiment. And when we have turned on the power factor capacitor, we need to make sure the power factor regulator can monitor the system. And after that, when we have monitored the power factor regulator, when the power factor regulator are on the good position, then we can turn on the power supply to give to consumer. That's all from me. Thank you.
Assalamualaikum and hi. My name is Aiman Fatina binti Muhammad Kamal. My matrix number is DE20094, and I will do video on bus bar coupling for M1, MSB1 and MSB2. Okay, now I'm in my PPE. This is a safety jacket. Okay, and I also changed my hijab because it is more comfortable. Okay, and then this is an helmet, but it doesn't have the for fire shield. And then this is a safety boot. Okay, I'm sorry because my camera is a bit low, so I have to stand back. Okay, and then this is a protective an earplug, because sometimes when we in the switch room or LSB room, sometimes it's quite noisy, so we need to have this one. Okay, right now I'm currently in a power station, so I will do my video lab showing the real LVSV unit, but I will only be using it as a background. Okay, because this power plant is in operation, so I cannot press any button, so I will just show the step by step. And then due to COVID, I have to follow the SOP. So right now can see my face, but after this I will wear mask. Okay, before we go to the LVSV room, I will explain why we need coupling MSB and MSB2. Okay, sometimes when fault occur, or the second one we want to do for maintenance purposes. Okay, so when we do this, there will be a certain load that needs to run immediately, so we need some backup supply to carry the load. Okay, that's when the MSB1 or MSB2 be functional. Hi, unfortunately I cannot record myself doing the lab in this power plant because the switchgear is a bit different from our switchgear. Okay, I will include the picture of switchgear here. The method is the same, actually the function is the same, but the procedure is a bit different from us. So I will only explain in picture. Okay, so the first thing is when we want to switch off the ACB, okay, the first thing we need to do is inform the control room or consumer that we want to turn off the supply, so they are noted by it and they are ready. When they are ready, just by when they are ready, so we can turn off the power supply. Okay, after we turn off the power supply, we turn off the load. Okay, after we turn off the load, we turn off the power factor. After that, we can check this in the ammeter. Okay, the ammeter must be 0. Okay, because we already turned off. Okay, after that, we go to the back side of this where have the insulator to turn off. Okay, when turn off, we can see the bus bar actually no light. Okay, after that, we can go to the ACB where we want to off. So have 2 buttons here. Okay, so first we need to push it here, so we'll have that sound like that. So now we can see the light, both of the light are turned off. So we can know this is de-energized. Okay, after that, we need to open here, have some lock here. We open it, we need to have the handle. Okay, the handle is used to rotate the ACB. Okay, so when we push it, we rotate it anti-clockwise, and then until it reach the isolator. Okay, after that, the ACB is actually already detached. So when we want to do maintenance, okay, we open it and we bring the ACB to the table or anywhere, and we do the maintenance. That's how we turn off the ACB. I'm sorry, I forgot. Okay, after we already pull out the ACB, okay, so we need to put a sign so and everyone knows that this is already disconnected. Okay, so I will put this sign over here. Okay, this is the real sign in this power plant. Okay, where they use when the circuit is in maintenance, something like that. So yeah, okay, so now is how we want to connect the load to the MSB2. Okay, so why we need this? So sometimes the load needs to run immediately when this is the MSB1 is being disconnected. So how we do this? By using coupling method. So MSB2 need to feed the load for MSB1. So this is called coupling. So what we should do is first we need to go to the ACB, okay, and we need to push this button. Okay, have 2 buttons. We need to push this button and push this button and then twist the key and pull. Okay. After that, we need to go to the insulator. Okay, here. Okay, insulator. Okay, these 2 have key already. Okay, this slope doesn't have key, so we put the key over here. Okay, we put the key over here. So when we put the key over here, we twist it. Okay, and we can pull these 2 keys, but first we pull this one lah. Okay, we pull this one and we put here 1 more slot key for here. Okay, we put here and then we pull this one. Okay, 1 key down here, we pull it and we bring this to the next insulator over here. Okay, so the next insulator, we put this the key over here up. Okay, so when we do that, okay, now the diagram is complete. How do we know which one to turn on? Okay, so it depends on condition. Have two condition, 1 feed 1, 2 feed 2. For this condition is actually MSB 2 feed 1. Therefore, we need to on the insulator, the nearest insulator to the MSB, which is now is MSB 2. Okay. After that, so after we turn the MSB 2, okay, so we turn the MSB 1. After we turn the MSB 1, now the bus bar light on the MSB 1 is on. Therefore, this is energized. Okay, so we want to on the AC supply. Before we on, we need to inform back the control room or the consumer we want to on. When they are ready, just by when they are ready, we can on it. Okay, so first we on backward. Okay, we start from the power factor to the load, and lastly to the AC supply. Okay, therefore this switch gear already complete. Okay, so we can do a maintenance over the AC SCB circuit that we already taken out. Okay, this is how to do coupling for MCB. Okay, this is PCA, and then this is PCB. Okay, so for this step, actually we want to transfer MCCB, okay, to here, MCCA. Okay, so how we want to do it is actually we need to tell the control room, okay, to transfer all this load to here.
Okay, after we notify the control room, this will be their view. Okay, so they will do the transfer the load to PCA, or they can also do turn off the transformer or turn on the transformer. Okay, this is a bit different from our lab, which is in our lab we will do it manually. For example, like we turn off the AC, and then we turn off the loads, and then we turn off the power factor. But here, all this will be done in the control room.
Okay, so when they transfer it, actually they'll transfer to here, a tie breaker.
A tie breaker is normally a breaker that can be closed to connect two separate systems together. This component is a bit different from our lab. Okay, when we want to supply the MSB2 to feed the load in MSB1, we will take a key from ASCB and we will put it in isolator 1 and isolator 2. So the function is the same, but a different component.
Okay, this tie breaker then will transfer all the load from here to here. Okay, this load will be 0 because all of this move to here. So when this is already been coupling, okay, so we need to tell the control room to shut down the step down transformer, which is 6.6K to 115 volt. 415 volt.
Okay, this is how a dry step down transformer looks like. Okay, it is 6.6K to 415 volt.
Okay, if this ACV is de-energized, so actually we can open here, okay, open like that, and we'll have tool over here. Okay, so how to rent out? So we can pull like that, so this will be come out. Okay, but we need to be like to go like this, then it will be de-energized.
Okay, this is how you turn the handle. Okay, you turn it anti-clockwise, you turn it until it reach the test isolated. Okay, after we disconnect it, we need to rack it out a bit because sometimes if have current, so the ACB won't be functional. And then after that, we will put sign so everyone will know that the component is in maintenance.
Okay, that's all from me. Thank you very much.
Okay, my name is Ahmad Izzat bin Ayer. Okay, today I would like to present about how to restore back to the normal supply. Okay, first thing we must inform our consumer that we want to turn off power supply. Okay, so here is our MSB 1 and our MSB 2. Okay, first we turn off our power supply, turn off, and lastly we turn off our capacitor factor. Okay, we can check the current MSB 1 here. It should be 0. After that, we turn on our isolator 1, and we can check the bus bar is we can check the bus bar supply is ready to energize. Okay, next we turn on our isolator C2 MSB 2. Okay, then we remove the key isolator C2 and key isolator C1. Okay, then we put here and here. Then we remove the key ACB. Okay, then after the maintenance already complete, we insert back the ACB. Okay, and then we turn in the key to clockwise. Then now ACB is isolated function. Okay, we need to give a power supply to MSB 1 first from isolator. And now MSB 1 already have power supply. We can check the voltage here. Okay, using the air rod, we turn to the clockwise until the ACB is the connect position. Okay, right now MSB is discharge and off position. So we must doing by using charging process. Okay, using for example at ACB they have a button to charging. Okay, we must doing like this until ASB is charged. Okay, after that we can turn on the ACB. Okay, turn on, and we can check at the bus bar is balance or not. Okay, after that we need to notify the consumer that our capacitor band is ready to turn on. Okay, we turn on the capacitor band and we turn on the RCCB and all load. Turn on. Okay, then we can check the current status is stable condition or not, and we wait for a while to make sure our system is stable condition. Okay, after all process has done, we must write in logbook all what we have done. Okay, so that's all the whole process to restore back to the normal supply. Okay, that's all. Thank you.